In the experimental lab, we provide room and equipment for anything experimental. This includes anything which has non-conventional sample preparations as well as analyses for which no automated machines are available. In addition to the general lab equipment, we also provide climate chambers, glove boxes, clean rooms, as well as a biosafety level 2 lab, which can be used to grow bacterial cultures.
One of the questions that we aim to answer here with experiments in this laboratory is how earth materials such as crystals form and grow. This knowledge is essential for various reasons, from understanding how rocks form and dissolve and how marine organisms build their shell and if they can continue to do so in an acidifying ocean, to how can we make mineral production processes more sustainable. We synthesize crystals under conditions that are representative of the Earth's environment, and we measure their size and charge during experimental time. Some of the materials that we make are sensitive to oxygen, so those we synthesize here in this glove box in an atmosphere that's oxygen-free. We also want to know what kind of materials we're making and what the shapes of the crystals are, and for that we use a range of different techniques, including electron microscopy and Raman spectroscopy.
We study organic molecules in meteorites because we're interested in what happens with these organic molecules after a meteorite has landed on the planet's surface. In the lab, we do several experiments. In the glove box, we soak meteorites in water and we analyze what is leaching out from the meteorite, organic molecules and elements from the rock. After the experiment, we also analyze what the effect is of soaking on the meteorite itself. In this chamber, we can simulate planetary environments. For example, we can simulate Mars. We can turn on the sun, we can adjust the atmosphere, and we can change the temperature. By combining these experiments, we can test the effect of all these environments on meteorites after they have landed on the planet's surface.
Raman spectroscopy is a technique that uses blue, red, or green laser light to stimulate vibrations in solids, gases, and liquids. The vibrations are characterized by the solid's chemistry and its structure. That means that if we can map the vibrations, we can identify different materials. In geoscience, we use Raman spectroscopy to look at rocks, to characterize the different components of meteorites, and to identify the things that we synthesize in the laboratory. Our Raman spectrometer is attached to a light microscope. This means that we can create 2D images of materials that are spatially resolved on the micrometer scale. This is basically slightly thinner than one of the strands of your own hair. If we can create these two-dimensional images, it means we can characterize different components in these complex materials.